Right, in this video, we're going to talk about binomial expansion and Pascal's triangle. Ever since we've been in algebra classes, the earlier algebra classes especially, we talked about these problems where you expand about the power of binomial. Let's talk about that for just a second here. If we have anything to the zero power, we know we get 1. A plus x plus y was just going to equal 1x plus y. If we square the binomial x plus y, we know we get 1x squared plus 2, you multiply and double, so xy plus 1y squared. And if we cube, you could multiply all this out, but we also get 1x cubed plus 3x squared y plus 3xy squared plus 1y cubed. There is a pattern in the numbers that we see here. 1, then 1, 1, 1, 1 plus 1 here makes 2, and 1 on the end. They all end with 1 on as their coefficients. 1 plus 2 makes 3, 2 plus 1 makes 3. This forms what we talk about when we talk about Pascal's triangle. The first row comes from anything raised to the zero power. The second row to the first power. Third row, row 3, etc. So you can use Pascal's triangle to help expand a binomial. Notice what happens. The two numbers above a number add together to make it. So if you start with 1 and then 1 and 1, 1 plus 1 in between makes a 2. 1 plus 2 makes a 3. 2 plus 1 makes a 3. Notice all of these begin with a 1. 1 plus 3 makes 4. 3 plus 3 makes 6, etc. as you can go on here. You can use this pattern to help you expand a binomial. So let's do one using Pascal's triangle. The coefficients from Pascal's triangle, this is to the 6th power. So we look back at we don't have that in here. So let's go ahead and fill in 6th power ourselves so we'll kind of know what we're doing here. We start with a 1. 1 plus 5 makes 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6, and end with a 1. So 1, 6, 15, 20, 15, 6, 1. So to expand your binomial, we're going to use that pattern to do this. So we've got 1 times the first term, x to the 6th power, and the negative 2xy, or 2y, I'm sorry, 2y to the 0 power. Okay? Plus 6 times x to the, we're going to start descending in power with the first term and ascending in power with the second. So negative 2y to the first. Plus, what was our next coefficient using Pascal's triangle? 15. So 15 x to the 4th. Negative 2y squared plus 20 x to the 3rd, negative 2y to the 3rd, 15 x to the 2nd, negative 2y to the 4th. Okay, with 15, 20, 15, go back to the Pascal's triangle, 6 and 1, okay? 6 times x to the 1st, negative 2y to the 5th, and then 1 times x to the 0 and negative 2y to the 6th. It's a lot of work, but now we're going to simplify this down. We can use our calculator all we need to. So on the first term, you've got a 1 times x to the 6th, and then this is to the 0, so this is a 1 also. So we know we've just got x to the 6th for our first term in our expansion. Okay? So check off that one. We've done it. Now the next one, you've got 6 times x to the 5th, and you've got negative 2y to the 1st. So that's just going to be 6 times negative 2. That's negative 12 x to the fifth, y. Okay, so done that term. On this one, you've got 15x to the fourth, and then negative 2 squared becomes 4. So that's just going to be 4 times 15. So that's 60. So plus 60 x to the fourth, y squared. Notice as my powers of x are descending, my powers of y are ascending. Done with that one. Okay, negative 2 to the third power is negative 8. Negative 8 times 20, so this is going to be negative 160 x cubed, y cubed. Okay, a little bit harder math going here. Negative 2 to the fourth is 16. 16 times 15. 240, and it's going to be positive this time. X squared, y to the fourth. Okay. Negative 2 to the fifth, that's negative 32 times 6. So negative 192 x y to the fifth. I didn't check these off. And then last term of the polynomial, we've got 1. We got 1. Negative 2 to the sixth power, that's going to be positive. So that's going to be plus 64y to the sixth. A lot of work. But I think Pascal's triangle is actually the easiest way to expand a binomial if you know how the pattern works.